we know that extreme weather is becoming increasingly volatile and more frequent. So I'd like to just hear from, I guess, the group, what is it about combining different types of Earth observations that's so powerful in allowing us to now predict these high impact weather events in advance? What is it about that combination of Earth observations?
All right, well, I'll take a first stab.
Yep.
So first of all, like the plethora of Earth observation data that we have today is mind-boggling. Our satellites go up on these rideshare launches, and every time we go up, we're one of probably 30 or 40 or maybe even 100 of these small satellites, many of which are Earth observations, just in different parts of the spectrum with different capabilities. And so we can see from all these different types of sensors, both the conditions that led to these severe weather events, and then we can also see the aftermath of the weather events. So, all the weather events, they start in the atmosphere. They start with a storm that might be originate thousands of miles from where the impact is eventually felt. So that's why you need the global coverage that the satellites provide. But then when you see the impact, you can see the storm itself. You can see whether it's the intense precipitation or the wind or lightning happening. You can see that all from the vantage point of the satellite. And then you can see the aftermath. Sometimes you can even see the flooding and inundation through these cloud penetrating synthetic aperture radar data sets as the event's happening. So we really have an unprecedented array of Earth observation data to examine the impacts of these storms in great detail today.
Well, I think to just add on to what Joe was saying, if you were to look at kind of two ways of looking at disasters, preparing for them and responding for them, Earth observations kind of, help do both of that, both in the short term, but also in the long term. You acquire a lot of data over the years, and you have historical data, which kind of helps you understand, how you can better prepare for an event. From that to, how do you respond? If there's a disaster, you cannot stop a disaster from happening, but then the disaster happens. How do you quickly respond to it? And he mentioned, synthetic aperture radar, which helps to, disaster management better. But then obviously from a short-term preparedness point of view, you know that there's a hurricane coming, but where is it going to hit? When is it going to hit? So, for a short-term, but also for the long-term preparedness, and also for the responsiveness is kind of where I feel like Earth observation is kind of bringing a holistic solution.
Yeah, just to give the third aspect of it, like the Earth observations underpin all our models, right? So we have our models, and the new ML models are coming in, but a lot of our classical NWP models solve the equations of motion, the conservation equations, but they are all underpinned by initial conditions, and they're given by the observations. And the big difference that we're now seeing with the Earth observations is you can have a lot of Earth observations, but in a small area, and that's not useful. I mean, it's useful, but it's not the whole picture, because weather doesn't follow terrestrial boundaries. And so having space-based Earth observations that cover the entire globe is just the next level of having something that provides us a full solution that can tell us how things are advancing and changing.